Welcome to Sigma Solver, guys. Before I start the video, I want you guys to smash the like button. This helps the YouTube algorithm and keeps me motivated. And if you are new here, then make sure to subscribe to my channel and press the bell icon so that you never miss an update. So, without any further ado, let's get started. Today we are going to discuss an important topic in cloud computing and Linux servers configuration as well. So let's read the question first to understand. The use of permission bits is an effective method for implementing the principle of least privilege in cloud service providing organizations. The permission bits associated with program prog1 and dataset data1 are as follows for a Unix or Linux based system. So this is the program 1 that we are given and this is data 1 that we are given. We are asked to describe the permissions provided by these bits for prog1 and data1 respectively. Then we are asked what security mechanism is being enforced by these permission bits. So first what we will try to understand is basically what is permission bits. So permission bits are a set of indicators that are used to control the access rights for different types of users to files and directories. In a Linux or Unix operating system, there are different files and directories associated to them which contain these files basically, and the access to them is granted by the permission bits that we are going to study now. These permission bits allow different users to play different roles in the same system in order to provide, say, functionalities like security and confidentiality stuff. So like if we proceed further, we see also each file is associated with a set of these permission bits. As I said, since security is concerned and it is for wide range of applications and files in the system, so each file needs to have a permission bit that basically tells the user that whether he is assigned to that file or he has the ability to view that file or not. Perfect. So next is basically permission bits. The format of permission bits is 9 binary digits, and in those 9 binary digits, if the digit is 1, it means permission is granted, and if the digit is 0, it means that the permission is denied. Next, we see that these 9 binary digits will now need to be grouped into 3 sets. We'll understand why this is important, but first let's understand that these 9 bits as a whole don't give any meaning. They need to be divided into these 3 sets in order to provide relevant information. Next, we see that in these 3 sets, the first set is that of the owner. Means the first 3 bits will denote what access permissions does the owner have. It is important that in Linux or Unix file systems, even the owner itself of the file can restrict himself in accessing the file from the next time. This is highly important for those files which are like important for a timestamp perspective, like once it is created we cannot change it or modification is less likely to occur and most probably a mistake. So in those cases owner can change the permission bits on his part to prohibit him from making changes in the future. Similarly, we have this group. Group is like the list of people specific who are associated with that file, means writing, updating, stuff like these. The next part is other. All the rest of the users that may be using the same Unix or Linux system, what permissions do they have with respect to the file? Whether they are allowed to read the file or not, that is something that we decide in the other category. Okay, next we move to the classification from above into the 3 given bits. So like each part, owner, group and other, will have 3 bits of their own. That's only how we make 9 bits in total. So each group classification now has 3 bits, which is read, write and execute. Let me explain them one by one. So read is associated with read contents of the file. Simple, it basically reads the contents of the file. Write it allows to modify or delete the file, the permission needed to modify or delete the file. Execute is only meant for scripts or programs that are written or stored as files into the Linux Unix system. So for those we'll have this bit set so that the person with access to that particular file can execute the file as well on the system. Okay, next is the program that we are given. Let's now understand that how we are going to deal on that. So if we see the first 3 bits, it will denote the owner, as I mentioned previously. So owner has 1 1 1. So the first bit is read, the second bit is write, and the third bit is execute. As you can see that all 3 bits are set. This means that owner is having or enjoying full permission to this particular program. Next we come to the group. So in group we see that the read bit is set, the write bit is unset, and the execute bit is set. This means that the group can read and execute the program, right, but does not have the permission to basically edit the program. It's simply like having a C program, and we can read the program and we can execute the program, but we cannot edit it. Okay, the last part is others. Others only have like the read functionality for the file, means they can read the file, read our C file, but they cannot write, modify or delete or execute the file on the system. So this is basically the permission bits that are set for the program 1. Others only have read only permission. Now we come to the data part. So in data part, this is the permission bits that we were given. So if we come down, in owner again we enjoy full permission because all the bits are set, means everything is granted to the owner, he has full permission. Next we come to group. So in group, the read bit is set, the write bit is unset, and execute bit is also unset. This means that the group associated with the file is only responsible for reading the file. If we come down to the others part, it does not have any permission. It does not have read permission, write or execute. This means the file will not even be visible to others using the system. Only the group that has permission to this file can actually access or read the file. Okay, so the next thing is basically the last part of the question, which is what security mechanism, cloud security mechanism is being enforced by this. So I want you guys to understand or pay attention here, because this is something that is very important. So the mechanism that we see here, you see that the program was only readable by the group, whereas it is both readable and executable by the group, and others can only read it. Okay, and the owner has full permission. So you see a increase in permission as we go up, right, and as we go down there is a decrease in permission. So what I want to emphasize here is, with every layer that is abstracting away from the file, we are reducing permissions. So that is the same case which goes in data as well. You see the owner has the entire access, the group has limited access, and others have even more limited access. So this is the principle of least privilege that is responsible for basically ensuring that security policies are put in place, and the person which does not need any unnecessary permission is not allocated to at the first hand. Means when we are adding a new member to our let's say software development team, then we will provide him or her only the permissions that he needs to perform the task. We will not provide him the entire permission and then just reduce what he does not need. That is not the way. Similarly, in cloud mechanism security functions, we can have this principle of least privilege to ensure security policies. That's been it. If you still have any doubt in this, then feel free to reach out in the comment section below. If you liked this video, then give it a thumbs up and subscribe to my channel for the upcoming videos. Till then, happy solving. Hey there, before you go, I've got some fantastic content lined up for you. Over here, we've got some videos and playlists you might enjoy. But first, if you haven't already, make sure to hit that subscribe button and ring the notification bell so that you never miss out on any of our future uploads. Thanks for watching, and I'll catch you in the next video.